right, so let's have a look at number 2 here first. So we have iron 3 bromide is reacting with sulfur. So what kind of reaction is that? Single replacement. Okay, the element is a non-metal, so sulfur is going to replace bromine. Right, so that's going to leave us with Fe and S, and then bromine is going to end up alone. Okay, this is already dropped and swapped correctly. Okay, that's a -2. This is a plus. Sorry, it's not swapped and dropped together. This is a -2. This is a +3. Okay, so we've got to drop and swap Fe2S3. Okay, there, and now we can balance the whole reaction. Okay, I would start with the sulfurs. 8 and 3. What's the lowest? Yeah, it's 24, right, is to get it there. So I got to put an 8 here, right, and a 3 here. That's going to give me 16 irons. So I've got to put a 16 there, and then I've got 16 times 3 is 48. So I'm going to need a 24 here to make the bromines work. Okay, big numbers. I probably wouldn't give you one of that big of numbers on a unit example. Let's throw you a curve and see how you handled it. Okay. Let's look at number 5 here. So I've got chromium, and this would be chromium 3 nitrate, or sorry, nitride, and it's going to be breaking down. So we got a decomposition reaction. So we're going to get chromium, and we're going to get nitrogen. We have to remember, decomposition reactions often produce special elements. We got to be on the lookout for those. Then we've got to come back here and put a 2 here and a 2 there to make it balance. All right. So the point of me having you do that one was, again, remember the special elements. They're crucial. Okay, for number 6, we have a double replacement reaction between barium phosphate and copper 2 sulfate. Okay, so in a double replacement reaction, the metals are going to switch. So barium will end up with sulfate. That's a -2, that's a +2, so that compound is fine. And then copper is going to end up with, not with sulfate, with phosphate. And on this side, I said that the copper was copper 2. How did I figure that out? Right, sulfate's a -2. Okay, so sulfate's a -2, copper had to be a +2. So now I need to drop and swap this one. Okay, knowing phosphate is a -3. Okay, so I'm going to Cu3 PO4 brackets 2. Okay, reason to have you do that one, remembering how to drop and swap a polyatomic ion using the brackets properly. Okay, now I've got to go back and balance everything. I'm going to put a 3 here to balance my barium. That's going to give me 3 sulfates, so I need to put a 3 here to balance the sulfates, which balances the copper, and everything else should be good. All right, for number 8, what kind of reaction is that? It's combustion reaction. Okay, so we have nonane. Okay, that's what this stuff is. Okay, and it's reacting with oxygen gas. We always produce carbon dioxide and water. Okay, do I need to use both balancing rules on this one? No, 9 is an odd number. Okay, so I'm going to put a 9 in front of the carbon because I'm balancing alphabetically. I've got 20 hydrogens, so I need a 10 here to balance that. That gives me 10 oxygens in the water, plus another 18 here for a total of 28. 14 times 2 is 28. Okay, are they all right with that one? All right, number 9, I've got a synthesis reaction involving nickel and phosphorus. Okay, reason I had to do this one is because I need to know which nickel I'm dealing with when I drop and swap this compound. Since it's an element on the reactant side, what do? I take the most common charge, which is the first one listed on your periodic table, which is 2. Okay, so this is +2. Okay, this is -3, so we're going to have Ni3P2 as our final product there. Okay, and if I'm balancing this, I'm going to need to put a 2 here to balance my phosphorus, and then a 6 here to balance the nickel. So the whole point of having you do that one was to remind you of that little rule about the multivalent metals. If there's no way to figure out the charge, you go with the most common, which is the first one listed. Okay, and then for number 10, okay, we've got zinc hydroxide reacting with potassium. What kind of reaction is that? A single replacement. Okay, potassium's the metal, so it's going to swap out with zinc. All right, so zinc is going to end up alone. Okay, potassium will end up with hydroxide. Do I need brackets on this one? No, I don't. Okay, it's already dropped and swapped correctly there, so I just got to go back and balance everything. I'm going to need a 2 here to balance the hydroxides and a 2 here to balance the potassium. Okay. All right. How are we feeling about the reaction stuff? Okay with that? Then I want you to try those 3 mole equation problems. Okay, we'll go over those in a few minutes. All right, so for number 1 here, okay, we've got we're looking for the mass. So number 1 is the one that obviously has the most steps. So it's kind of like our 5-mark kind of question here. Okay, so what we know right now is we know the number of molecules. Okay, 1.2 times 10 to the 24. Okay, and we know that it's magnesium fluoride. So MgF2. All right, so we're going to have 24.31 plus 19.0. All right, on yours. Times 2. All right, so we got 62.31 as our molar mass. Grams per mole. All right, so now that we know that, we can use the number of molecules to help us find N. Okay, so we're going to take number of molecules. Okay, we're going to divide that by Avogadro's number. Okay, and that'll give us our number of moles. Okay, because obviously Avogadro's number is the number of molecules in 1 mole. Okay. That's not what I want. Go away. Go away. Go away. Okay. All right. So we've got our 1.2 times 10 to the 24 divided by 6.02 times 10 to the 23. All right, so we're looking at 1.99 moles. All right, now that we have that, okay, now we can calculate the mass, because mass is n times big M, okay, and we have big M already, and we just calculated what N was. So 1.99 times 62.31, okay, we're going to get about 125 or so. Okay, 124.21. And that'll be in grams. Okay. Ring a bell on that one? Yeah. Okay. For number... Whoops. Okay, for number 2, we're looking for the mass of 16 moles of lead bromide. So they told us N, 16 moles. Okay, they told us the material, lead 2 bromide. So that'll be PbBr2. Because obviously the Roman numeral tells me to use the 2 plus when I drop and swap. All right, so lead is 207.2. Okay, plus 79.9 times 2. Okay, 367 grams per mole. All right, everybody okay with that so far? Okay, so now if I want to find the mass, all I have to do is manipulate the mole equation. Okay, so N equals little m over big M, multiply both sides by M. Okay, plug in my numbers. So 367 times 16. So we have obviously quite a bit of this stuff. All right, so we're looking at 5,872 grams. Right, everybody okay with that one? And then number 3, that's the easiest one, okay, because we're just looking for number of moles. Okay, we're told the material, iron 3 nitrate. So that's Fe with the 3 plus charge bonded to nitrate, which is a -1, so we'll need brackets and the 3 outside of them. So we'll have 55.85 plus 14.01 times 3.
Isn't that a 2, Mr. Coder?
Right, it's
Iron
2. Iron 2. You're right. F-E-N-O-3. Sorry about that. 55.85 plus 2 nitrogens. That's 28.02, right? And we're looking at 6 oxygens. All right, so 179.87 grams per mole. Okay, and we're just looking to calculate N, so we don't even have to manipulate the equation. Now, last couple of unit exams, I've had a question like this one, where I made the easiest mole equation calculation involve a polyatomic ion. As a result, the question did not go well. Okay? Not because people didn't know how to plug numbers into the mole equations, but because they didn't do this correctly. Okay? They just put in something other than, like, if it was nitrate, they put in nitride. Okay? Or they didn't swap and drop, or silly things like that. Right? Or like what I did. I put a 3 in instead of a 2. Silly mistakes, but we got to watch for those things, right? Okay, so we have 390 grams divided by 179.87. Okay, so we're looking at 2.17 moles. Okay. Monday's test on the theme of simple things and silly mistakes. Units. When you're doing your mole equation calculations, make sure your final answer has units on it, and most importantly, has the correct units on it. Okay? If it's supposed to be mass, it's in grams. If it's supposed to be number of moles, it should be moles. Okay? Make sure that you are putting units on there, including if you find the number of molecules, then your units are molecules. Okay? Put that on there. If you forget your units, it'll cost you a mark. Okay? We don't want to forget units. Okay? Over the weekend, remember what I told you the other day, okay? Try not to study for extended periods. Try and take breaks in your studying, okay, so that you can process what you have put in your brain, okay? Remember that it is, of course, still important to look over your notes, but more important than your notes is practicing your skills. Chemistry is very much a skill-based science. Most of your marks are based on demonstrating your skills. That would be performing mole equation calculations, predicting, balancing, writing chemical reactions, all of that kind of stuff. So make sure that your skills are polished for Monday, because that's where the bulk of the marks reside on the test. Okay? What do you need to bring with you on Monday?
Pencil, AutoCAD.
Pencil, right. Bring your periodic table.
Calculator.
Your calculator, yeah. Okay? You have to have a scientific calculator for Monday. Okay? I went out and bought 3 cheapo scientific calculators last night. Okay? So I have a couple of loaners, 3 loaners. Okay? If somebody was to forget theirs. Okay? Don't forget yours. If you're the 4th person to forget, you're in big trouble. Okay? I would want to do a mole equation calculation by long division. Okay? By hand on paper. I wouldn't want to do that.
I like forgotten by now.
Okay? So make sure you come prepared on Monday. Like maybe right now, put a reminder in your phone for Monday morning. Okay? Put it in your calendar and say, remember, calculator, periodic table, pencils. Okay? Put it in there so you don't forget. Okay? And you come prepared. Bring what you would normally bring. Just make sure you have those things, right? During the test, obviously, guys, all that can be out on your desk is the test, your periodic table, and your calculator. Okay, your books, binders, whatever else has to be put away. So maybe don't bring them at all. Okay, just bring what you need for the test. Remember also that your phones will be in this bin. Okay, during the test, they will be powered down. Okay, they cannot be on for a couple of reasons. Okay, if you have it on and you haven't put your smartwatch in here, if you have a smartwatch, it also has to be working. Okay, it can obviously still communicate with your phone. But even more importantly than that, it's really annoying when you're super popular and you haven't turned your phone off and it's vibrating inside this box. Okay? Then I have to go looking through the box for which phone is vibrating and annoying everybody. And throw it out the window. Yeah. Or in the toilet. I wouldn't really do that. But hey, yeah, just make sure, guys, it's really loud. It's really distracting if that happens. So it needs to be powered down before it's put in the bin. Okay? And then I will give you your test paper as well as your multiple choice bubble form. All right? So just make sure you're filling it in as you go. Okay? We talked about that the other day. Just be ready for Monday. Okay, remainder of class is yours to work on your studying or your, well, you can work on your toxin project, you can do it on your phone. Okay, that kind of stuff. So it's up to you, but hey, let's get to work on that stuff there, guys. Okay, guys, sorry, a good question just came up here. I'll remind you and show you again where the review package is. I posted it last Thursday, so it's just in the stream. Okay, you'll just have to go back. Okay, so I did the unit exam review yesterday, so that podcast is in the stream from yesterday's post. Okay, as well as the mole equation stuff. But if you go back to last week, okay, right here, September 26th, Unit 1 exam review package. Okay, so there they are. Those are the files you'll need. One's the key and one's just the assignment itself. Okay, and then obviously the podcast I did yesterday is yesterday's post. So that's where you'll find those.